Stars You Should Know, Southern Skies edition on episode 380 of the Actual Astronomy Podcast. I'm Chris, and joining me is Shane. We are amateur astronomers who love looking up in the night sky, and this podcast is for everybody who likes going out under the stars. We have several Patreon supporters to thank. First, Dave, do you mind if we do that?
No, go right ahead.
All right. Who are we thanking this morning, Shane?
Well, like you said, there's a whole lot. It was fast and furious the last week. So big thanks to our new Patreon supporters who are Patrick, Jim, Thomas, Richard, Charles, Jacob, Bob, Michael. So thank you very much for becoming supporters. And as always, thank you to all of our Patreon supporters. We really do appreciate it.
Yeah, it's most appreciated. We're also doing a calendar draw. What's the story with that?
Well, so you procured a few extra RASC observers calendars for 2024, and we're going to give them away to some randomly drawn Patreon supporters. So the draw will happen on December the 10th, probably announced on the December 11th episode. So you still have a little bit of time if you want to become a Patreon supporter and get your name thrown into the hat. But how many are we giving away, Chris? Three?
Three.
Okay.
Three. For sure. Do you want a calendar, Dave?
I've got plenty, thanks.
And why is that? You're a contributor to the calendar. That's why.
Yeah, I am. I'm along with Diane Brooks. I have contributed the historical anniversaries for, I can't remember how many years now, but it's always fun to collaborate with her and put those in. And when people get their calendars, not every date, but 2 or 3 a month, I think there's some nifty little anniversary of somebody being born or something being discovered or what have you. So it's a lot of fun.
And in addition to that, you also provide some generous proofreading.
Oh, yes.
My work. I appreciate that very much.
Yeah, I have a bad case of editoritis.
It's okay. We hope that you live a long and ill life with this illness.
Yeah. I'm the kind of guy that corrects menus in restaurants. That's not how you spell that.
The hamburger's fine, but I'm sending the menu back.
Yeah, something like that.
All right. Speaking of Dave's background, he is a retired scientist, a longtime collaborator of mine. He's been on the show many times. He's a fellow of the Royal Astronomical Society of Canada, past editor of the RASC's Observer's Handbook, and a longtime contributor to the journal. Most recently, he collaborated with Kathy LeBlanc on the Mi'kmaq Moons book, The Seasons in Mi'kmaq. And we're going to welcome Dave back to the show to talk about the Stars You Should Know Southern Skies edition. Welcome, Dave.
Well, thanks for having me back. I guess this is the 6th episode in the Stars You Should Know series, and it kind of wraps it up. We did Northern Stars, and we did 4 seasons of stars for, I guess basically Northern Hemisphere observers. And now we're going to do the Southern Stars. So the Southern Stars.
But Dave, before we get going,
yes,
you were talking about a special star that we talked about last month, Enif.
No, we're not going there.
Well, I had made a corny joke, but I wanted to start there because I used Enif last night when I was testing my observatory for the first time. I was having trouble with the alignment because we had jinky power connector at -7 degrees. And I kept having to do the alignment. And I was looking towards the west. Yeah. And I wanted a star that wasn't too far to do that second star. And all the stars that we were getting were the stars in the Big Dipper, the stars in Orion, which was basically just on the eastern horizon, stars in Gemini. And then finally I saw Enif come up. And I was like, I know where Enif is. And that's the star that I want because it's the shortest swing. So I punched in Enif and I was like, I'm going to tell Dave this tomorrow that I used the Stars You Should Know when I was doing my alignment for my telescope.
So we should tell the listeners that Enif is the star that's marks the snout of Pegasus, the nose. And it's a classic navigation star and is also used in Skywatcher and Celestron mounts that used star names. Nowadays, you can get systems that just take a picture of the sky and get you going, so you don't even have to learn the star names. But some of us still have some of these older style mounts, and anyway, it's always fun to learn the names of things.
It was useful. It was
well,
useful.
good. I'm glad I helped you out there, man.
Yeah. Sorry for the bad jokes.
So, as usual, we're going to be looking at the classic names for these stars in the southern sky. Although I have to say it's a little different, because a lot of these stars are new. Like, they're not Greek and Roman, because some of these stars the Greeks never, and constellations the Greeks never saw. So many of these are pretty modern in the sense of that they were named by European astronomers and different explorers, and that in like the 16th century, 17th century. So you'll see the names are a little bit different from normal, and there's not as many classical Greek legends associated with them. It's a very interesting series. So these stars, if you lived in the southern hemisphere, these stars would probably be almost circumpolar, depending on how far south you lived. But they're not of you wouldn't be able to see most of these from Canada, let's say. However, I checked it out, and if you go to the southern states, like let's say the Florida Keys, or maybe deep southern California into northern Mexico or into the Caribbean, you should be able to pick out all of these stars, although not all on the same date. It would be seasonally dependent. So if you do make a trip down that way, you'll be able to see some of these stars if you find yourself in a dark sky area with clear skies. And as usual, we're going to talk about the spectral classes of the stars, O, B, A, F, G, K, M, which were invented or refined by Annie Jump Cannon, and they span the color spectrum from sort of blue-white through white and yellow and orange and red. So there's a lot to be learned there. And I want to make a little side note here that didn't go into the show notes, but when I was on vacation, I read a really great book that I recommend, and it's called The Glass Universe by David Sobel. Do you guys, either of you, know that book?
I do not.
Okay. So the reason you should read this book is that it's a history of specifically about the female astronomers and so-called computers and people who analyzed the plates in the Harvard Observatory. Many of them were never considered to be full-fledged astronomers, but they worked very hard, and many of them noticed patterns in the stars and their variability. They were excellent interpreters of the glass plates. And so, for instance, like Annie Jump Cannon started seeing patterns. They were looking at spectra, by the way. They were black and white, but they were dispersed by a spectrum. But also you come across names like Henrietta Leavitt and the lady who discovered the Cepheid variables. Help me out here. It was on the tip of my tongue, but all of these observations and pattern recognition were done long before anybody knew anything about the physics behind them. So they were interpreting spectra like fingerprints and noticing patterns, but this is long before modern physics and the explanation for these lines and whatnot. So it's an incredible story. It's called The Glass Universe, and that's referring to the glass plates they observed on. It's very detailed, well-researched, well-written. Dava Sobel has written other good books like Longitude and Galileo's Daughter. The book has been around long enough that you might even be able to pick it up at your local library or as an ebook or a physical book, and I highly recommend it. So let's just jump in, right? So I picked out 12 bright stars from magnitude minus 0.6 to magnitude 2.4. And I have to tell you that for this one, there were so many interesting stars. I really had to throw a couple of good ones out of to get it down to 12. There's many more interesting stars in the southern sky because it's so rich. You're looking in the direction of the center of the galaxy. And there's just so many things to look at. So all 12 of these stars are celestial navigation stars. And I'm not going to mention that again. Just remember, all of them are celestial navigation stars. All 12 are used by Celestron as sky alignment stars. And I'm not going to mention that again. Here's the interesting fact. Out of these 12 stars, only one is used by Skywatcher. And I thought that was a very interesting observation. Like in all of the other ones I've done, there's been about the same number of Skywatcher stars as Celestial stars, but Skywatcher doesn't seem that interested in the southern sky stars. Anyway, and I've already mentioned that they're visible from the Caribbean and the extreme southern continental USA. So this isn't simply a virtual description. Hopefully, people will be able to go down on their trips when they go south and see some of these stars and remark on them. Before we get into the stars themselves, I just want to mention a defunct constellation, and it's called Argo Navis. And this is a very large ancient constellation that represented the boat that Jason and the Argonauts used when they went to search for the Golden Fleece. And huge constellation, but it ended up getting broken up by a guy named Nicolas Louis de Lacaille in 1756, and people went along with that. So it got broken up into the modern constellations Carina, which is the hull of the ship or the keel, Puppis, which is the stern, and we covered that before in Winter Stars because it's just underneath. It's far enough north; it's just underneath Orion, and you can see Puppis from Canada, and Vela, which are the sails. So there's Argo Navis becomes Carina, Puppis, and Vela in the modern system of constellations, and we're going to jump right into that. We're going to talk about Carina, which is the hull or keel of Argo Navis.
Let's set sail.
Let's set sail. So the star that I'm starting out with, because this is the one that I always look for when I go south in the winter, because it's called Canopus or Canopus, and it's Alpha Carina, and it represents the pilot of the ship, the person who's steering the ship, and it is the second brightest star in the night sky. So the only one brighter is Sirius, and it's way south of Sirius. So when you go south, you see Orion, you go down, you look at Sirius, keep on going, and you'll see Canopus. And I'm always like on the bus, if it's night, if it's on the bus going to the resort, I like look out the window, like, can I see Canopus? And when I see it, I think, oh yeah, okay, there it is. So I always have fun looking for that. So it's a magnitude, it's a negative 0.6, and it's a spectral class A9 white supergiant, lovely star. And for the pop culture aspect of this star is that I have never read the sci-fi novel Dune or seen the movie, but it's associated with that novel Dune, and the planet Arrakis is the third planet of Canopus. Fictionally speaking.
That's a good movie.
Yeah? Should I watch the movie or read the book?
You should do both. I think you should read the book first. It's a big book, but you're a man of many words.
I heard the movie sucked, though. Anyway,
which one?
Dune. Well, there's more than one?
Yeah, there's more than one. I know some people don't like it. It's a David Lynch film. I'm a big David Lynch fan.
Oh, okay. Yeah. Twin Peaks.
Yeah.
Right?
If you like that kind of stuff, then. Whoa. But it's not like that. It's not like that. It's.
Okay. Okay, I'll do that. Maybe I'll get it on my reader for my next trip south, and I'll read it and then go out and look at it. Yeah. That sounds pretty cool, actually.
Yeah.
Okay, so I've mentioned that all of these stars we're going to talk about are used in celestial navigation, but some of these bright stars are actually used by spacecraft. Okay, to orient themselves when they're out in space, and Canopus is one of those. So it's still used for navigation. I mean, literally navigation of spacecraft through the solar system. So, and I don't know what the other ones are, but that might be a homework assignment for somebody to see what stars are used by spacecraft to orient. So that's enough about Canopus. It's a favorite star of mine. The other star I picked from Carina has the name Avior, and its Bayer name is Epsilon Carinae. And what's interesting about it is that for a long time it didn't have a proper name, but when Her Majesty's Nautical Almanac Office was continuing to publish the ephemeris for all the stars for navigation purposes, somebody decided that all the navigation stars needed to have proper names, and Epsilon Carina did not have one. And so they applied the name Avior to it. And more than that, I do not know why they chose that particular name or if it has any particular meaning. But it's a magnitude 1.9. It's a spectroscopic binary, and it's a variable star. And by spectroscopic binary I would say that almost no telescope would be able to separate this star into its components. It can only be observed as binary by looking at the Doppler shift in the spectral lines. So that normally a star would just have a spectral line, and then when they're zipping around one another, one will be coming towards you, one will go away from you. So one will get shifted a little to the red and another to the blue. So the spectral line splits, and that splitting has a period to it. So they can actually measure the period of the spectroscopic binary. And that's the kind of thing that those ladies did that I was mentioning at the top of the show. They would observe these things, and they had really good pattern recognition capabilities. So it's a K3. I guess the primary must be a K3 orange star, and its other claim to fame is it's the brightest member of an asterism called the False Cross, because people go looking for the Southern Cross, and they're looking for 4 stars in a cross shape. And there's this other asterism called the False Cross, which is sometimes mistaken for crooks. I might have even done that myself on occasion. And it's the brightest member of that False Cross. So there you go. So now we're going to pop over to Centaurus. Lots of neat stuff in Centaurus. Centaurus is the centaur. Now there is a map that goes in the notes with this, so these are all marked out on the map. So Centaurus, yeah.
Sorry, Dave. I just thought maybe a good time to mention that we will post the show notes.
Yes.
So for anybody listening, you don't have to write all of this down. You can just go to actualastronomy.com, and all of these details will be there.
The things that I'm reading off my sheet are exactly what's on the show notes. So you don't have to scribble all this stuff down. There might be a few side comments that don't make it on the notes, but anyway, Centaurus is kind of below and to one side of Scorpius in the sky. So we never see it. I mean, like if you go out in the summer and you see Scorpius, somewhere below that is Centaur. But I'll get to that. So the brightest star in Centaurus is a star called Rigel Centaurus, or Rigel Centaurus, which is the foot of the Centaur. So you've heard that name with a slightly different spelling in Orion, because Rigel is the foot of Orion, particularly I think the left foot, but anyway, no matter. So Rigel Centaurus is the foot of the Centaur, and it's a magnitude 0.0 triple star. And it's a G2. That's not much different from the Earth, our sun, which I think is G3. It's a yellow star. And Rigel Centaurus is the third brightest star in the night sky. Most people don't use that name. Most people just call it Alpha Centauri. That's how you'd know it, I guess. Now, here's the really cool thing, and I'm going to put you guys on the spot. It's the nearest star system to Earth, other than, well, no, that's correct. It's the nearest star system to Earth because the sun is solo. So it's got at least three. It's got at least 3 components. So the brightest 2 are easy to see at a telescope, but then there's a third star, and it has the name Proxima Centauri. Now, the reason it's called Proxima is that of those 3 stars, it is in fact the closest star to us, other than the sun. And this is one of the trick questions I ask people when I'm giving them freebies at outreach. I always say you can have a star, you can have a sky. What do you call those things? The sky.
Planisphere?
The planispheres, yeah, the RASC ones. People come and say, "Can I have one of these?" And I said, "Yeah, but you need to answer a skill testing question." And I'll say, "What's the closest star to Earth?" And anyway, I kind of make them work hard, right? And there's a bunch of different right answers. And anyway, so Proxima Centauri.
So is that your question for us? Are we supposed
no,
to?
No. That's too easy for you. This is the question. Proxima Centauri is part of a multiple star system. Now, I want you to tell me or guess how far in angular spread is, and don't look this up. You're not allowed to look it up. How far in the sky is Proxima Centauri from Alpha Centauri?
No idea.
No idea?
I'm going to say, Chris? I feel like it's far. I've looked at them. I feel like it's far. Is it like 30 arc minutes?
Okay. The true answer is it's a hair over 2 degrees. They're 2 degrees apart.
It's far. Like I knew it was far. I just didn't know it was quite that far.
Well, and it's far because it's so close, right?
Yeah.
So, but I was astonished when I read that it's a red dwarf. It'd be really hard to find, I think,
because I've split them in my 7x35s. I mean, you can split splitting them is not. Yeah.
So you've seen Proxima?
Yeah,
the red dwarf. Okay, good. Well, we should move on.
Or no, is it super faint? Maybe I saw another star.
I think it's probably super faint.
Oh, okay.
Something like 60-70% of the stars in the galaxy are red dwarfs, and we don't see hardly any of them. It's the most populous kind. So the other star that goes along with Alpha Centauri, of course, is Beta Centauri. And as far as I can make out, the name Hadar has something to do like it's one of a pair. And they are pretty close in the sky and both fairly bright. The names are often a little bit, hard to figure out. And many stars go by different names according to the culture and language. So anyway, it's a magnitude 0.6 variable star, a B1 blue-white. And so here's how it's useful. If you go from Alpha Centauri to, let's see, I've got this backwards now. No, if I go from, Alpha Centauri to Beta Centauri and keep on going, that's like pointer stars to get to the true Southern Cross. You should be able to pick the Southern Cross out in the sky if you're looking, but if you need a guidepost, you can follow Alpha Centauri to Beta Centauri to get there. And if you're a deep sky observer, not far away, I don't know how many degrees, but while you're in that vicinity, you might want to go and look at Omega Centauri globular cluster, which is a very, very impressive globular cluster. It's so bright that Ptolemy and those guys mistook it for a fuzzy star. They didn't realize what it was until much later, but they gave it they labeled it as a star, Omega Centauri. Later they found out, oh, this isn't a star, it's a cluster of stars. So anyway, it's definitely worth looking for. Shane, if you take your binoculars south in January, you should be able to pick that one out.
Yeah, awesome.
So there's many interesting stars in Centaurus. I'm going to move on to a star named Menkent, which is okay. So this is a favorite of mine. It's Theta Centauri. It doesn't really have much to recommend it. It represents the shoulder of the Centaur. It's a magnitude 2.1 binary star, a K0 spectral class orange. The reason I included it in this list is that this star is visible from Canada. And I'm going to say I discovered it one time when I was in Kejimkujik. It was an exceptionally clear night, and there wasn't very much haze at the tree line, and it was summertime, and I was just kind of looking over, and I saw this star, and what the hell's that? Like, what constellation is that? And I looked it up. I looked at it, and it turned out it was in Centaurus. And I said, I didn't realize that you could see any of the stars of Centaurus from Canada. Now, I mean, we're 45 degrees north here, so that might not work where you guys live. But anyway, Nova Scotia, we were able to see it. So that's kind of cool. So it's kind of like a little pet star for me, Menkent. Moving on from Centaurus, where are we jumping to now? Oh, Eridanus. Why am I going to Eridanus?
Eridanus, the river.
Eridanus?
I love Eridanus.
Well, yeah, there's a lot. There's only one star in Eridanus.
Isn't it Achenar? I'm just
Achenar. Yeah, Achenar.
Yeah.
That is okay. There's an interesting story here. So Eridanus, whatever, is the river, and some people feel that it represents the Nile because it's north-south, right? And apparently, there's not many rivers in the world that flow north-south. Like all the other great rivers go east-west.
Mm-hmm.
I don't know. I haven't researched that, but that's kind of an interesting observation. Anyway, it's the river, some kind of a river. Now, in the early days, there was a different star that was called the end of the river. And that was because the people that were looking at the river couldn't see its end. And when people started exploring into the southern hemisphere and going farther south, they extended Eridanus, and they found another star. And they said, well, the river keeps on going. So what they did was they transferred this end of the river name to that star. And that's the one we're talking about now, Achernar. And the old one has a very similar sounding name called Achamar. So there's Achernar and Achamar. Anyway, that's another one I look for when I'm in down south. It's kind of opposite in the sky to the Centaurus star. So if you're lucky, if you go the right time, the right season, you might be able to pick them both. But like one, you might have to get up in the morning to see, like Centaurus. The other one, you try to catch it just before it sets after dark. And here's another useful thing about Achernar. When I have been in the south and doing observing and setting up maybe a little star tracker camera mount, it's really hard to pinpoint the south celestial pole because there's no bright star there. There is a star near it, but you can't see it with your naked eye. You'd have to use a telescope. But there's a couple of ways you can find this or estimate where the south celestial pole is. One is that, and I'll tell you the second one later, but this one, if you can find Hadar and Achernar, the south celestial pole is almost exactly halfway between those two stars. And when I was down in Chile, that's what I was using to sort of roughly point my star tracker, just to get it in the right ballpark so I could take, some time exposures. And as you go along that line, you pass between the small Magellanic Cloud and the large Magellanic Cloud. So there's another useful thing about Achernar, why you should know that star. So we've been talking about the Southern Cross, Crux. And wow, there's a lot to say about this, but I have to keep it short. So the Southern Cross is featured on the flags of Australia, New Zealand, Brazil, and possibly others. I don't know. There may be other countries that have the Southern Cross. It's a very well-known graphic. You see it a lot, the shape of the Southern Cross. And it's important in the star lore of several cultures. Again, we're kind of giving you the Western astronomy view. We'd love to spend time talking about the Maori and the Aboriginal and the African indigenous peoples. But I think you should maybe find somebody who knows a lot about that, because there's a lot more to be said. It was known to Ptolemy in Alexandria. And that is because at the time Ptolemy was observing, and before that, it was actually far enough north that you could see it from. Well, I guess Alexandria was considered to be part of Greece, I think, at the time. But he actually made a note of it because of. But then precession of the equinoxes moved it south and below the horizon, and it became invisible to the Europeans and Northern Africans. The brightest star, Alpha Cruxis, has the, It's called Acrux because nobody had a real name for it. I think the IAU might be looking for alternative names to try to represent some of the other cultures that inhabit the southern hemisphere. But they've been giving some indigenous names to stars, but I don't know if these are up for grabs. So the four brightest stars in Crux are called Acrux, Bacrux, Gaycrux, and oh gosh, what's the last one? Hey, Alpha, Beta, Gamma.
I bet you then some crooks.
Anyway, the Acrux is it's a pretty bright star. Alpha, it's a magnitude 0.7 multiple star, B 0.5 blue white, and in a small telescope, it's a nice double. So there you go, Shane. It might be an argument for taking a small telescope down south. Nothing. I can't say too much more about it. There is a lot of, like I say, there's a lot of sky lore involving this constellation, but we need to move on. So Gaycrux, and I guess also it's Acrux and Gaycrux or Gacrux are the navigation stars and the alignment stars. So that's why I've sort of singled them out. So Gaycrux or Gacrux is Gamma Crucis. It's a magnitude 1.6 variable multiple star. It's an spectral type M3.5, red, orange. And that's the other thing that's cool about the stars in Crux. They're all different colors. And if you take a picture and if you don't saturate the exposure, you can see the colors. But Alpha Crucis and Gamma Crucis it's another way to find your way south, because they are pointer stars to the south celestial pole. And again, there's no bright star there. But if you see the Southern Cross in the sky and you want to know like which way is south, just follow Acrux and Gaycrux to find that. Yeah. And it will also intersect that other line that I mentioned. So it kind of gives you a better idea what the southern celestial pole is. So it's a lovely star grouping if you ever get down there. You've been down before, Shade, haven't you?
Yeah, multiple times down to that latitude. Caribbean and Hawaii.
If you're there in, you said January, I think you're going to have to get up like a little bit before dawn to see those stars.
Yeah, a lot of this fun stuff is probably, at its apex from roughly 2:30 a.m. until sunrise, depending what I want to observe.
Yeah, the really rich part of the Milky Way is early pre-dawn at that time of year. Yeah. That reminds me, I went down many trips to Cuba. Somebody asked me to do a star tour with my laser pointer, and it was November. And I said, yeah, we want you to go out and show everybody the stars. So I go out, and I always start with the Big Dipper and the North Star. I went out, and I couldn't find the Big Dipper. I was like, what the hell? And then I realized I was like 20 degrees north, and the Big Dipper was entirely under the horizon. I was lost.
It's funny you say that. I was at a wedding in 2018 in Cuba, and the same thing. We were on the beach, and people were asking me what constellations we were looking at. And I couldn't find the Big Dipper, and I was like, I have no idea what we're looking at.
I know, but we've been down on the beach, and I've gone down, and I say, well, there's the Big Dipper rising above the horizon, and like, what? Big Dipper circumpolar? Well, now here it is. Yeah, it's fun. You get a whole different perspective on the sky when you go to another part of the world, especially north south.
Yeah.
So we're going to move on. This is a bit of an obscure constellation. It's called Grus, which is the crane.
I thought it was Grus.
Grus? Okay. Grus. I have a hard time. I'm sorry. I can't pronounce these. I should check the pronunciations, shouldn't I?
Could be. I'm probably wrong, because I think the last time you're all wrong.
Grus. Yeah. Well, if you do get a observer's handbook, there's a page. I can't remember the number, but there's a page where all this is all worked out for you, how to pronounce the names of the constellations and the stars. I just haven't studied it enough. My defense is that I don't look at this one very much. So now where is that? Where's Grus? Okay, it's in a pretty sparse area of the southern sky. And anyway, it has its principal star Alpha is called Alnair, and it means that means the bright one. In other words, all the other stars are dim. And this is, if you look at that part of the sky, it's the bright one, and that's the one that's the navigation star. So you need some on that side of the sky, but it is a very sparse area of the sky, as is many of the ones that are following here. So Alpha Grucis, I don't know, is a magnitude 1.7 subgiant. It's a spectral class B7. It's a blue-white star. Unfortunately, it has the same name as another star in Centaurus. I don't know why people do this. It has the same name as Zeta Centauri. So don't get confused. And I have no more to say about that, other than it's one of these stars you should know if you're trying to align your telescope or find your way around the, what is it, the Great Horn? What's the when you're navigating around the bottom of South America? What is it?
The Southern Horn.
The Southern Horn or something. Here's an interesting one. Not far. It's called
Cape Horn.
Sorry?
Cape Horn. Is that what we're talking
Cape
about?
Horn. Yeah,
Yes.
Cape Horn, right. So Pavo is the peacock, but apparently Pavo is also used in some languages to represent a turkey. So,
well, it was just Thanksgiving for our American
Pavo.
friends. Yeah.
And so anyway, the brightest star is Alpha Pavonis, maybe. And so like I was saying before, because there's not a lot, these stars weren't known to the ancients. So the name of the star is Peacock. Somebody just, okay, we'll give it. And again, it was named by the UK Nautical Almanac Office in 1937 because they came up with this new rule that all of the navigation stars had to have proper names. So people said, well, let's just call it the Peacock. That's why it has a very plain, ordinary English name and not, something that sounds Latin or something or Arabic. It's a magnitude 1.9 subgiant, another subgiant. It's a multiple star, spectral class B2.5, blue-white. And again, that's all I have to say about it. It's in another. This is in this part of the sky that's kind of opposite the really interesting area, which is like Centaurus and Crux and Carina and all those. And then we get back to Vela, which is, remember, that's one of the sub-constellations of Argo Navis. And that's the sail of Argo Navis. And here's an interesting thing. When they broke up Argo Navis into the three constellations, they didn't relabel them. Like, in other words, Alpha Carina was the brightest star in the whole of Argo Navis. But when they broke it up into three constellations, there isn't an Alpha or Beta Vela. The brightest star in Vela is Gamma, because it was Gamma before, right? So it has the Arabic name Suhail al-Mulif, the glorious star of the oath. And so there's it's a double star. The Gamma 1 is magnitude 1.8. It's an O class blue star. Gamma 2 is a magnitude 2.2 multiple star, and it's orange red, a K star. I'm trying to think if Gamma 1 and Gamma 2 are naked eye. You can split them naked eye. I think so. I think they're given those labels because you can see them by eye, but they're part of a double star system. It also has the modern name Regor, and that is Roger named spelled backwards. And this came about because Gus Grissom, one of the astronauts, I guess he was having trouble with the names of the stars, so he started renaming stars, and so he named that one Regor for Roger Chaffee, and he and Gus Grissom were lost in the Apollo. No, the Apollo, was it number 1 that had the fire? anyway, people have kept that name in honor of that of those guys. But again, there's another star in Vela, also named Suhail, the glorious star of something. So it can get very confusing down there. You have to make sure you get the right one, right? So the last star we're going to look at is in the constellation Phoenix, which is, it's called Phoenix, and it represents the phoenix. Now that's the famous, in legend, the phoenix is, I have to see if I can get this correct now. The phoenix has a long life, and at the end of its life, it is consumed by fire, and a baby phoenix, a young phoenix, rises from the ashes of the fire, and that becomes the new phoenix. Okay, more than that, I don't know, but that's, you often hear this in pop culture about the phoenix rising from the ashes, but it's the baby phoenix that rises from the ashes. And so Alpha Phoenix. Oh God, I don't know what the genitive case is. The alpha star is Anka, which I think is just another word for phoenix. And it's for a navigation star, it's a bit dim. It's magnitude 2.4. It's another one of those spectroscopic binary stars that I was talking about. And it is a spectral class K, yellow-orange star. And this is the one Skywatcher alignment star in this list. And I don't know if there's a story behind that, but Skywatcher didn't care about these southern stars. There are some other southern stars that Skywatcher uses, but they're not on this list. I had to cut it down to 12. But when you start looking at the southern sky, there's a lot of really interesting stars and objects, and I had to cut it down to the top 12 in my view. So there you have it.
Well, that's awesome, Dave.
Yeah, real interesting list. And as we discussed before pressing record, I'm pleased with the timing for my southern travels.
Yeah. Well, yeah. You might want to, I don't know what kind of planetarium software you use, but you might want to plan out your observing sessions there, and make a list for yourself. Chris actually gave me a bunch of binocular targets one time. You remember that, Chris? You sent me a list of the things.
Oh yeah, I forgot about that.
And I put them in Sky Safari, and then I can just call up Chris Beckett's Southern Sky Splendors, and
which I've never seen.
And then you can highlight them and then go for them. You see, I find having a list is really useful for observing, because especially when there's a graphic interface where these things are circled, and you can sort of say, oh yeah, like there's something I can go for. And I don't know what you use. What do you use, Shane?
Sky Safari is my go-to.
I should be able to send you that my Chris Beckett Sky Safari list then.
Yeah, that would be great.
I'll see if how to do that. I think I can share those. I'm not sure what. I'm guessing it's probably for the winter sky, Chris? Because I usually go down like January, February. So
yeah, I can't recall. I did see many of them because I did go to Hawaii and do a lot of the observations.
Yeah. Anyhow, I've had the pleasure of being in the southern hemisphere a couple of times, where these things are all circumpolar, and I've also been to the Caribbean many times. So I'm getting pretty familiar with these stars and constellations, and I always enjoy observing them. So for the people out there in podcast land, if you are planning a trip south for a vacation, you should look into maybe observing some of these bright stars and identifying the constellations, and you can amaze your friends. How are we doing for time?
We're doing good for time. One thing, though, that we're a little bit remiss on is that, and I was going to run this by you guys, we didn't do our conversation on green stars. And I actually broke out a couple notes, and I was thinking, since we're coming up to the holidays, maybe And although it's not a St. Patrick's Day holiday, maybe we'll do a very quick Green Star special. We could just end this recording and do another one. And what do you guys think?
Sure.
Yeah,
all right.
I like it.
Have I got time to tell a quick story?
Do you want to do? Is it to do with these stars, or do you want to tell it in the next episode?
It has nothing to do with these stars. It has to do with my last trip down south. And
okay,
my do you mind?
Go ahead.
Okay, so I was out enjoying my what was I drinking? I was drinking a pre-dinner drink. I think it was anyway.
Shamrock really Shake.
No. It was anyway. Don't matter. What's the one with tequila and that in it?
Margarita.
Yeah, I was having a margarita, and we sit in this bar which is off the lobby of the hotel. But the reason we like to sit there is because I can look up and see the sky. And I sit there and I look up and I say, hey, there's the Summer Triangle still up there hanging around. And then I heard a conversation at the next table. And this lady was talking to the waiter and she was complaining. She said, where's the moon? Why can't I see the moon? I expected to see the moon. And he's like, I don't know. Like he was flummoxed, right? And she had this idea that here she was and she, and so I called over to her. I said, hey, it's the new moon. It's the time of the new moon. And she turned around and she said, what? I said, it's the new moon. She said, what does that mean? I said, well, the moon goes around the earth and right now it's in the direction of the sun, so you can't see it. Oh. I said, actually, a few days ago, you could go out in the morning and see it in the morning sky. What time did you get up? Anyway, turns out she didn't get up very early. And so she said,
those at the bar often don't.
Yes. So she said, well, so are you some kind of professor or something? I said, no. I said, I'm not a professor. I've never taken or given an astronomy course. However, I do have an asteroid named after me. and she said, get out of town. I said, if you want me to prove it, I'll come over and show you where it is in the sky with my name on it. And she said, no, okay, that's really cool. Thanks very much. Anyway, that was, and I said, a couple more days and you'll see the crescent moon in the sky, if you're still here. But then I never saw her again.
Well, Dave, yeah. Thanks for the story. Thanks for joining us. It's always a stellar time having you on the show to talk about stars you should know.
Yeah, well, stellar. Yeah.
Good stuff. Anything to add, Shane, before we conclude?
No, just thanks again, Dave. Always enjoy the conversations and hearing you talk. And this particular series of Stars You Should Know has been very informative for me. And I know a lot of the listeners just based on the emails we've received. So yeah, thanks a lot, Dave.
Well, that's great. I've really enjoyed preparing it. And I guess people could, listen to it. It's kind of evergreen. People could go back and listen to it in other years if they know it exists. But yeah, I've had a lot of fun. Thank you.
And thanks everybody for listening. Be sure to share the show with other stargazers you know, and you can enter our Patreon calendar draw by becoming a Patreon supporter. And if you want to send us your show ideas, observations, and questions, please email us at actualastronomy@gmail.com.
Thank you everyone for listening, and we hope you enjoyed the show. If you are interested in more information, would like to contact us, or if you would like to support the podcast, check out our website, actualastronomy.com.